part 2 of the question states that find greatest distance of body from O. What does this, how are we supposed to interpret this? What did you do in order to find the greatest distance when you are given s equals to 24 t squared minus t cubed? From here, how do we find the greatest s? Okay, differentiate s to get velocity. So what should I do after I get my velocity? Set it v equals 0. Okay. Set this v equals 0. Then I will be able to generate t. What is this t supposed to represent? Time when v equals 0. So these are turning points. Okay, we will reach the greatest distance either at a turning point, or if there is, for example, a linear graph. It goes on forever and ever. There's no turning point. Then, in that case, the greatest distance will be infinity. Now, in the case of the presence of turning points, these are very essential, very significant points that we need to take note of. Okay, and in this case, it will correspond to one of the greatest distances. Then, for question 7. Cyclists travel in a straight line. Traveling in a straight line from, okay, like this, from left to right or right to left, they are both considered in a straight line. When they turn, they can also turn along the straight line. It is an immediate U-turn. Okay, they don't turn one round. Now, in this case, our displacement S, which is measured in meters, from a reference point O. This is the origin. Okay? They say that it is given by S equals to 4 plus 15 t minus t cubed. T is the time in seconds after passing a point X. So let us assume that he started from the origin. Then he started traveling to the right. Let us take the right direction as positive. So as he is traveling, the timer has not started yet. What this question is trying to tell us is that t is the time in seconds after passing a point X. So suppose he was over here. This is the point X. Now over here, as he is passing through it, we start our timer. So t equals to 0 lies over here. Okay? In other words, we are able to find the distance of OX simply by substituting t equals to 0 inside here. Mental sums, we know that S is going to be equal to 4. Therefore, OX is equal to 4 meters. It tells us the start state. When time equals 0, our displacement is already 4. It has already started before we started timing. So the part 2, 3, and 4. Okay, part 2 and part 3, straightforward questions. The part 4, I'm focusing on the interpretation of the questions. Calculate distance traveled during the 3rd second. Distance traveled during 3rd second. This refers to distance from time equals to 2 to time equals to 3. So you are supposed to find the distance traveled between these two timings. And to do so, find the displacement at time equals to 3, minus away whichever is greater, minus the displacement at time equals to 2. You take the bigger displacement minus the smaller displacement so that you will obtain a positive distance. This is with the assumption that there are no turning points between time equals to 2 and time equals to 3. Because if there is a turning point within time equals to 2 and time equals to 3, then you will also need to take that into consideration. Are you all following what I'm saying? Any questions? Raise our hand now. Okay, does anybody need the detailed working for question 7? especially part 4. Wrong answer, is it? Okay, so let's do part 4. So S equals to 4 plus 15, t minus t cubed. OX equals to 4 meters. This is when t equals to 0. Part 2, find the velocity. So v equals to ds over dt. 15 minus 3t squared when t equals to 2. V is 15 minus 3 times 4, and we get 3 meters per second. Part 3, acceleration when he is instantaneously at rest. So instantaneously at rest means velocity equals 0. When v equals to 0, 15 minus 3t squared equals to 0. This tells me that t equals to plus minus root 5. But can time be negative? Okay, so no, we reject negative. Because time cannot be negative. Okay, so I know that when time is equal to positive root 5, it came to a rest instantaneously at that point in time. In this case, it's going to mean that he is doing a U-turn. And now we want to find the acceleration. A is dv over dt. Differentiate this, negative 6t. When t equals to root 5, A is negative 6 root 5 meters per square second. Now, time equals to root 5. What is the value of root 5? 2 point, okay, can't see, but it is roughly 2.236 seconds. At time equals to 2.236 seconds, it made a U-turn. Okay, so now on this part 4 already. Calculate distance traveled during the third second. That means we are interested in the distance traveled from t equals to 2 to t equals to 3. So as mentioned, we will draw our displacement axis. It is far more useful to draw a displacement axis than a time axis, because we can visualize where he is at whichever time he is at. So at time equals to 0, we know that his displacement is 4. Okay, so this time equals to 0. Some key timings that we are interested will be time equals to 2. When time equals to 2, our displacement is equals to 4 plus 4. Okay, substitute that in. What do you get? Oh. Times 2 minus 8. What's the value? 26. Okay, 26. So 26 is going to lie on the right hand side of 4. Somewhere here. This, take note, this is the displacement. Displacement from the origin, which we earlier on said is over here. Okay, just that we didn't start the timer over here. We started a timer when he's at a displacement of positive 4. So from t equals 0 to t equals to 2, he has covered up to 26 meters away from O. He is going to continue traveling because he didn't turn at time equals to 2. Continue traveling to the right until time equals to 2.236, which is square root 5. Okay, and that's when he does the U-turn. So we need the displacement when time equals to root 5. When t equals to root 5 as 4 plus 15 root 5 minus root 5 power 3. And how much is this? 26.3606. This is what you all calculate. I hope you all are correct. So 26.3606 is slightly to the right of this 26 over here. 26.3606. This over here is time equals to root 5. And what did he do here? U-turn. Change direction. I would love to be able to draw from here, then I draw it this way in red so that you can see he is literally on the same line. But very difficult to see, especially if you are using just one color. That is why we tend to draw it this way. Okay? We exaggerate that turn over there, but you must know it is still on the same line. So it's going to turn to the left. The next timing that we are interested is when time equals to 3. So due to a lack of space, I shall do it over here. When t equals to 3, s will be 4 plus 15 times 3 minus 3 power 3. And how much is this now? 22. If this is 22, you have to figure out where 22 lies on your horizontal axis. It must be before 26, isn't it? That means from here, he has arrived to this point. And this is time equals to 3. So the distance that we are interested from time equals to 2 to time equals to 3 is as shown. Okay, this portion. Mental sums, how much is this in yellow? Okay, so let's write that down. Total distance is 26.3606 minus 26. We know that this refers to the first region. Then we still need to add something else. We need to add the portion on top. Let me highlight it in green. This distance, how much is that? How did you get it? So we are dealing with distances. So this green region will be 26.3606 minus away 22. So these are the two portions that we need to add up to get our final answer. And it should be correct. Can somebody help me confirm? It's correct? Okay, so you get the answer. And then you round off to 3SF. Any questions? Huh? Why don't I add the first second? You mean, why don't I consider the distances over here, is it? Because the questions ask for calculate distance traveled during the third second. Okay. English lesson now, you don't understand already? So does anybody need me to explain? What does third second mean? Yeah, okay, that's a good analogy. During the third period. Does that work? Okay, so let's say our lesson start at 0800 to 0900. That's the first period, 0900 to 1000. Okay, so these are the three periods that we have. This is the first period. You can consider this as the first second. So the first second actually, or rather, first, okay, might be confusing. Let's not use this. Let's use time. This is now my timeline. Okay, from time equals 0, 1, 2, 3. The first second refers to this part. From time equals 0 to time equals 1. This is the second second. This is the first second. And then this is the third second. Okay? Better? Now next, and our final question, 11. Do you all need help? Part 3. Okay? So Now we have s equals to ln 2t plus 3. And again, it is moving in a straight line. Initial position, okay, just sub t equals 0. But to find velocity, we will require that. Velocity is ds over dt. So over 2t plus 3 and 2 on top. This is our velocity. Next, part 3. Show that it is decelerating for all t. What do you think they are trying to get us to do? Okay, good interpretation. Show that acceleration is negative. Because I mentioned to you before, deceleration, another word for it is negative acceleration. So apparently we are now trying to prove that acceleration is negative. Do you even have an expression for acceleration yet? At this point, not yet. What can we find? Very simple, ma. This is just 2 times of 2t plus 3 power minus 1. I wrote it this way because I don't want to use my quotient rule. But you can use it. You can go ahead and use it if you want to, okay? So a is equals to 2 times of negative 1, 2t plus 3 power negative 2 times 2, resulting in negative 4 over 2t plus 3 squared. This is my expression for acceleration. And if you had interpreted it correctly, your job is to show that this is negative for all values of t. Have you actually shown that already? Is this going to be negative regardless of t? Why? Angel, understand? Okay. Numerator over here is just a constant 4. It is positive. Not the denominator is a perfect square, means it is greater than or equal to 0. It will never be negative. So positive divided by positive. Of course, we are going to disregard the denominator equal to 0 because you can't divide by 0. Anyway, for the denominator to be 0, time has to be negative, which is not possible also. So we can safely conclude that the denominator is positive. Positive divided by positive is positive. Negative times positive is negative. So this is less than 0 for all t. Finished. Shown. Alright. Again, traveling in a straight line, velocity is equal to times of 2 minus 5 e power negative t. And this is where t is the time in seconds after leaving a fixed point O. This, please go and highlight this statement, this phrase. T is time after leaving O. Okay, so this tells us that when t equals to 0, s equals to 0. Now this s over here is displacement from O. This is very important for us to identify what the value of c is later on. Because we are probably going to be integrating total distance for the second part. Okay, so let me just get part 1 out of the way. Acceleration is dv over dt. And we have 5 times of, what's this? 5e power negative t. 25 e power negative t, correct? So acceleration. When t equals to 2, a equals to 25 e power negative 2. Then go and find the value, round it off, 3sf. Total distance in the first 3 seconds. Please don't just think that total distance is just displacement when t equals to 3. We need to find out if there are any turning points. Okay, so when asked to find distance. Check for turning points. That is when v equals to 0. Must do that. Otherwise, they might as well ask you for displacement, right? If you don't want to check for turning point, you might as well ask you for displacement. Because that's what you're going to be giving us when you substitute whatever time, in this case time equal to 3, into our expression for s, which is displacement. Okay, so let v equals to 0. When v equals to 0, 5e power negative t equals to 2. E power negative t is 2 over 5. My unknown is in the power. I have to use my logarithms. In this case, let's use ln. Negative t equals to ln 2 over 5. Ln 2 over 5. Is that positive or negative? Think about it. Ln 2 over 5. Negative, right? Because 2 over 5 is less than 1. So this portion is negative. When I make t the subject, I will get negative ln 2 over 5. Do you have any insights over here? Now this part is negative, right? Times a negative sign, what do we have? Positive. Does that make sense? Yes. Because time has to be positive. Okay, so all this makes sense, huh? If you ever come to a stage where your time is negative, then you know something went wrong already. So these are the insights that you should be having as you are doing. Okay, so we know that there's a U-turn over here. It's traveling to the right, it U-turn when time equals to negative ln 2 over 5. Ln 2 over 5, although it is exact, it doesn't help me visualize exactly what that number is. So let's use our calculator. So this is approximately how much? 0.92. Okay. Distance traveled in the first 3 seconds. Draw your displacement axis. When time equals to 0, displacement equals 0. So t equals to 0 over here. Is that it? When time equals 0, is displacement equals 0? I think I just made an assumption. Okay, let's check. When t equals to... Oh yeah, correct. They say that time is in seconds after leaving a fixed point. Okay, so this is t equals 0. It is found over here. In the first 3 seconds, so we are interested in a few points in time. First is of course when time equals 0, because they want total distance in the first 3 seconds. The next one we are interested is when time equals to 0.92 seconds. Okay, so when time equals to 0.92 seconds, it made a U-turn. What is the displacement over there? 0.92, or rather, let's put in the exact value. Negative ln 2 over 5. Okay, our displacement is, we haven't found an expression for displacement yet. Let's do that quickly. Yeah, it is time now to integrate. Now, v equals to 5 times of 2 minus 5e power negative t. Expand it out, 10 minus 25e negative t. As is integrate 10 minus 25e power negative t with respect to time. Sorry, I'm working a bit haphazard. Now from here, integrate 10t. Integrate negative 25e power negative t minus, just copy it down first, 25e power negative t divided by differentiate the power. Okay? Then over here, we need to plus a constant c. Simplify this, we get 10t plus 25e power negative t plus c. This is our expression for displacement. Okay? Is c equal to 0 in this case? Why? when you sub time goes to 0, what do we expect? When t equals 0, displacement has to be equal to 0, right? Okay, let's see whether we end up c goes to 0. When t equals to 0, we know that s has to be equal to 0. Do the substitution. 10 times 0 plus 25 e power negative 0 plus c has to be equal to 0. Okay? Now this is just 0. 25 e power 0 is 25 plus c equals to 0. Does that mean that c equals 0? What is c now? C is negative 25. So you need to check your assumptions, if any. This means that my expression for my displacement is now changed to become 10t plus 25 e power negative t minus 25. Okay? Now I can finally substitute all my t values inside my expression for displacement, and I wanted to find out what is the displacement when time equals to negative ln 2/5. Do a quick substitution. Plus 25 e power negative ln 2/5. So one definitely can be simplified, minus 25. So from here we will be able to get a value for s. This is s when time equals to negative ln 2/5. So it reached at a point over here. Then beyond that, we know that this is about 0.92 seconds only. It made a U-turn. Continue traveling for another 4.08 seconds. No, 3 seconds only. It continued traveling for another 2.08 seconds. So you need to substitute time equals to 2.0. No, time equals to 3. Find all the distances traveled. I'm sure from here it is just geometry. You can just add up the distances. Okay? Let's practice now 7. I will do up the solution for practice now 8. I will upload it. I will also upload the 3 homework questions we have for exercise 16b to be completed over the weekend. Any questions?